Alright folks, I want to present to you a little tool I create to solve one of DevOps problem, which is synchronize Git source configurations to a console key value uh, system. So this is the final architecture, but I will show you just the little tool I create, which is a command line application. So the final solution would be storing Git config, storing config files and config key values on a Git repository. Once this Git repository is set up, we will have some operator in the Kubernetes will run a Git sync sidecar that will pull that information from the Git and will sync that information. All files will be synced to a console key value. So this is the container that it will create and that runs this command line tool that will take the files and sync to the console key value. So this part of the architecture is what I want to show you. So we do know that I'm researching a little bit, and we have some open source projects that do this, but they don't do the whole picture. That like they try to sync the files from the Git directed to console key value, and they keep that in the source code, and it's not maintainable anymore. The last source code that I saw has 8 years, is 8 years old, so it's not being maintained anymore. So I decided to create my own solution. So what will happen is that this tool will only take the files from the file system and upload to console. So this is one piece of the puzzle, and you can run that tool. You can run that tool inside your machine, and that's fine. But we also want to automate that as well. So the way it works is that we will have this git sync sidecar. This is a code that is from Kubernetes and is being maintainable. So this piece of the code here that will periodically pull the git config files, it's open source part that is being maintainable, so I will just reuse that. So we pull the git files and we'll sync them with the console files. So the final solution will have an operator with something like this. So we will have a console key value custom resource definition that will take just a key and a static value and upload to the console key value. So this is a simple approach. You can keep all your configurations inside custom resource definitions. The problem with that is that now you will have 3 places where you have configurations. You have configurations on your Git repository, and you also have configurations inside the custom resource definition, because Kubernetes will keep that information inside the metadata. So once you apply that information, it knows that it has changed. So you effectively have that information inside etcd database. So maybe you don't want to do that. So this is great for simple key value approach, so it's good enough. But if you have files that can span a little bit more of a size, so you should not keep them both etcd. So now you have to worry about etcd storage and also the console storage. It's not something desirable. So what you can do now, this will be a new custom resource definition called console file sync. So this console file sync will span, the operator will create a deployment that will have a pod with two two containers. One sidecar container that will pull periodically the config files, and one container that will have the two I will show you. So also they save the console config and the secret file, so it will use that. You can also authenticate in the GitHub, and you use that to spawn that pod. So this is the secret and the config file. So something like that. This is not ready yet, but the two to synchronize is. So let me show you the two. Now I have a console test folder which has this structure. So it has a config folder, apps config folder. So this is very annoying. Apps folder and application properties. So kind of just Spring Boot configuration or something like that. So you could have a cloud config, which is another application which have a different port, and a front UI which has a config in JSON and have a key and a test to key. So we also have a script, can be anything, could be test files, could be a Docker run file. So this is just a test, so let me remove that, and this is also a test. So let me show you how this works. So the code is written in Rust. It's not my main language, so but Rust is amazing because you can have a very small binary with a very small memory footprint. So could be written in Go as well, but I prefer Rust. So what this code will do, this is a single line code. So this is a clean code. So you could actually, let me show you in the new shell, in the shell. So let me run this. So key val sync. So let me run the target debug console value sync. So I want to synchronize the folder, the test folder that I show you, and I want to ignore the scripts folder that is inside the relative path of this folder. So if I try to run this, it will say that it needs the token, and it also needs it actually get the console errors by default, but we need to pass a token. So I will pass a token in an environment variable. So here's my token, and I also need to change the console address because my address doesn't work if I use localhost. So now that I have the, you can also pass as an argument to the CLI, but now I want to just run this. So it shows me that it upload the key, config apps, application properties, config all the properties that we have here, ignoring the scripts folder. So if we go to the key value, so this was empty, and if I refresh, we should have the mirror of the structure of the folder. Consider that the folder is, the root folder is console test, so it will be a relative path, and it will create the config and the test files. Now it also creates a metadata key folder, so it mirrors the content of the root folder. So it has a test.2 file that has the contents of the test. So if I change it for Kelvin, it's my son, it should run again, but you may notice one thing. So it uploaded only the test.2 text file. So how this happened, right? So how it knows that only the text.2 file have changed. So this is done using the metadata. So the metadata, so it has uploaded, Calvin is my son, and the metadata has a hash, and this hash is compared every time. So it downloads the hash and it compares with the hash of the file. So it will only upload if you change anything. It also has a permit override, so it defaults to true. So what happens is that every time you change something, Kevin, my son, change it, it will compare the hashes and upload. But what happens if you don't want that? So if you want the test2 file to stay the same, you could add, let's suppose you change the file. So like Calvin, it's my son and he is smart. So I don't want this file to be overridden. So what could be happen is that you can say in the metadata that this is forbidden. So the default is the false and save. So now even if you have some changes, it will ignore the change. So let's run again. It will say that no file is changed. So no matter what I put here, not matter, it will ignore that file. So if I change another file, let's run this tests. If I change another file, it will upload only that config file. It will not change. It will not touch the test.2 file. No. It will just ignore it. Now, what happens if I remove the ignore? So now it uploads the scripts and it knows that the config file has no change. It will upload the default. So this can sync every file, and it also utilizes the console transaction API. So it will do everything at once. It will not have stale files when you upload it, so you don't risk to being partial files in the console key value. So I hope this is helpful and you could utilize that. So it's not open source yet, and I do not publish the final file because I need to create some CI/CD pipeline to build that, target all Linux and Windows and also ARM. So I hope that can be helpful for you. So if you like that, if you know that this could be helpful for you in your DevOps, so you could give me a thumbs up and add a comment here in this video, and watch the what for updates, so I could improve and add this as an open source product. So thank you for watching. Have a nice day.